Good day guys, Secure Mathways back again with another video. So now, as you can see on the board, on my previous video I had already stated that when I'm breaking these ones down, I'm breaking them fully and I'm teaching you more when it comes to algebra. Remember, mostly when I teach as CK Mathways, when I teach, mostly it's based on CAPS curriculum, South African curriculum, understand? These kinds of problems, the way I solve them, I accommodate those who are doing CAPS. Also, I accommodate a different type of a curriculum now, which is out of South Africa. But here in SA, mostly the way I solve them now with those complex numbers, we call it AP Maths, Advanced Programmed Mathematics. That's how we call it, AP Maths, Advanced Problem Mathematics. So that's how I solve them. But hence, as I'm solving them, I'll guide you. If you are watching the video and you're a grade 10, you're a grade 11, you're a grade 12 learner in South Africa, then I'll show you where to end with the problem. But you know, also I started solving these problems while I was at your level in grade 10, grade 11, grade 12 from 2017. So it also helps to critically think about these, break them down. As I once made an example of a block, when you open the cube into the net, now understand, it shows you that the cube was like this, then now it's like this once it's folded. So that's what I want you to understand when it comes to these problems. They're not just a shortcut, they have more solutions, but it's just that we choose to end where we are supposed to end because of the limit from the curriculum we are doing, understand? So come with me now, let me show you this. This one, it has x plus 1, x plus 2, x plus 3, x plus 4, then is equals to 120. We want to solve what is going to be x here. Now, these are factors. First factor, second factor, third factor, fourth factor, which is equals to 120. And you can see it 1, 2, 3, 4. Mostly, when it comes to this advanced program mathematics, when we get something like, I'm not sure whether is it, I think it's probability. Probability. And I think, I'm not quite sure whether is it metric. I no longer remember very well. I'm mixing concepts, but you can fix me on the comment section, where we use factorials. Factorials. Factorials, something like if we're going to say 4, for example, if we say 4, okay, let me just not make this example, but let's just continue on this one. But the factorials, né? So as long as you see the factors that keep on 1, 2, 3, 4, 5, 6, 7, you can say just 7 factorials, which shows 1, 2, 3, and all that. Even on probability, it's something that we're doing. Yeah, I'm no longer quite sure. I'm mixing a lot of concepts in my brain right now. But let's jump to this one. This one, now we have x plus 1, x plus 2, x plus 3, x plus 4. Someone can use factorials, but it's fine. I'm not going to jump to factorials for this. I just want to solve it in a basic way. Now, if you see 1, 2, 3, 4, these are factors. What you're supposed to do, you are supposed to already from these 4 factors follow a foil. You understand? A foil, but a foil, it's not that we are doing this and this, this and this. No, foil, the outer ones, we group them, of which we're going to have x plus 1 as well as the x plus 4. Those are the outer ones. Yeah, but we first multiply the outer ones, then we multiply the inner ones, x plus 2 as well as x plus 3, which is equals to 120. Now then this one, it's just the ones that we're going to do foil, and these ones we're going to do foil here. On the inner ones, these are the outer ones. Né? So we're going to say x plus x, we're going to get x squared, x times 4, plus 4x plus x, then 1 times 4 plus 4. Then here x times x, we get x squared, x times 3, we get 3x, plus 2x, plus 6, which is equals to 120. And you see that, then once we have this now, I want us to simplify this so that you can see something. X squared plus 5x plus 4, then x squared plus 5x plus 6, which is equals to 120. Look at this. Can you see when you're looking at these two brackets? You can simply see that we have x squared plus 5x and x squared plus 5x here. Then this is plus 4 plus 6. You can make it in a form of trinomials. In terms of this is 4, you can change this 6 to be 4 plus 2 so that you can have trinomials. If you want to use trinomials. If you don't want to use trinomials, but let's make it simple to trinomials. Let's do this. X squared plus 5x plus 4. Then this is going to be x squared plus 5x plus 4 plus 2, which is equals to 120. Yeah, let's make it in a form of factorials. So we can let x squared plus 5x plus 4 to be equals to k. We can use k, we can use whatever letter you want. Why? Because we have something that is common. So we see this trinomial, we'll put k. For example, this one, we'll put k, we open bracket here, we put k plus 2, which is equals to 120. Then this is going to be k times k, which is k squared plus k times 2, which is 2k. Then we transpose this one to this side, which is going to be 120, which is equals to 0. Understand? Now, there's also a simple method I want to show you when it comes to factorization. I just thought of it when I come across this one. Because, for example, 120, when you're thinking of the factors of 120, you will see that the factors there, it could be 12 times 10, right? And we know that in order for us to find 12 times 10, what is it? How do we operate them in order for us to find 2? I'll show you how to simplify this in a simple way. But due to already here, the factors, I know them. Let's just do this. K and K. Then we're going to have 12 and 10 to get 120. But we need minus. And also here we must get a positive one. So we can just say positive here, minus here. So that we get K, which is equals to negative 12. Or our K, which is equals to 10. And remember, it goes back to that because the problem here, we are solving x, not k. So we have two values now. We're going to go back to that expression of ours, which is k, which is equals to x squared plus 5x plus 4. So where we see k, we put 10 first. 10, which is equals to x squared plus 5x plus 4, right? Then we transpose this one. So we're going to have x squared plus 5x plus 4 minus 10 equals to 0. We are also doing the same thing with negative 12. So we're going to say this side, our k is equals to x squared plus 5x plus 4, where we have negative 12 here, which is equals to x squared plus 5x plus 4. Then obviously, we take our 12 that side. We're going to have our x squared plus 5x plus 4 plus 12, which is equals to 0. Let me separate here so that you can see everything properly. Yeah. Now, what do we have? Here, we have x squared plus 5x, 4 minus 10 minus 6, which is equals to 0. Then we factorize this one. Even here, I'm going to show you how to factorize this. Here we have 6 then. We have 6, so we want 5. We can use 6 and 1, so that in order for us to get positive, we can do this. Then our x can be equals to negative 6 or x equals to 1. Now, let's focus on that one. That one is going to be x squared plus 5x plus 4 plus 12. 16, which is equals to 0. Can you see now this is very big, then this is 1. So we're going to use quadratic. So when we're using quadratic, x is going to be negative b plus minus square root of b squared minus 4ac over 2a. Now, these problems, as I said, these problems at some point, they need you to relax a little bit. Negative b here, we're going to get 5. So negative into, we put that 5 plus minus square root of b squared, obviously we said it's 5, which is going to be 25. 25 minus 4 multiplied by 16, it's going to be 64 over 2. Then this is going to be negative 5 plus minus 25 minus 64. What do we get there? 25 minus 64, get negative 39. Negative 39. Already, can you see now it's leading you to complex numbers? Why? Simply because this one is negative. So it's going to be negative 5 plus minus square root of 39 times square root of negative 1 over 2, which is going to be equals to, let's do this, put it in the calculator, negative 5 plus square root of 39 over 2, we get negative 5 plus 39. Okay, so we're going to leave it as negative 5 plus minus square root of 39i over 2. Then these are the two solutions again of x. So another solution here is going to be x, which is equals to negative 5 plus square root of 39i over 2. Another one, which is x, which is equals to negative 5 minus square root of 39i over 2. Then your solutions, it's 1, 2, 3, 4. 4 solutions. When we solve this fully. So yeah, guys, I'm not trying to complicate anything, but I'm trying to show you way more. Where do they end at some point? Complex numbers, which is AP. So you can study them. You can follow me for more. Keep on liking. I'll still show you a lot more of these kinds of problems. Thank you so much. See you on my next video.